up and then I'm gonna take it down. I'ma turn it up and then I'm gonna take it down. I'ma turn it up and then I'm gonna take it down. I'ma turn it up and then I'm gonna take it down. I'ma turn it up and then I'm gonna take it down.
Welcome to the very first episode of Visual Learners Podcasts. Today, we're diving into the fascinating world of quantum computing. Imagine a computer that can solve complex problems in seconds, problems that would take traditional computers years to crack. This technology has the potential to revolutionize industries, from medicine to finance. We'll explore how quantum bits, or qubits, work and why they're a game changer. Plus, we'll discuss the ethical implications of such powerful technology. Buckle up, because we're about to embark on a journey through the future of tech.
All right, diving right in today, listeners have been buzzing about this one, quantum computing. Is it the next big thing, or is it, well, hype? We've got a stack of research right here ready to break it all down.
It's a good one to break down. What's so interesting about quantum computing is that this isn't just like a faster computer, right? It's completely different from the computers we're all used to.
Yeah, so let's start there. I keep hearing this term, qubits. Is that the quantum version of a bit? What makes them so special?
That's it. Imagine a bit in your laptop is like a coin, heads or tails, 1 or 0. Qubits.
Yeah.
They're like a spinning coin. Until you look at it, it's both heads and tails at the same time. It's called superposition, and it's a big deal.
So instead of just being faster, it's like exponentially more powerful, because each qubit can hold so much more information.
Exactly. That means quantum computers can tackle problems that would make a regular computer completely freeze up. It'd be like trying to map out every single atom in this...
In this microphone.
Sure, in this microphone.
Yeah.
Classical computers got to look at every atom one by one. A quantum computer. Superposition lets it look at them all at the same time. That's where things get really interesting.
That's wild. Okay, there was another crazy concept in the research, entanglement. What's that all about?
Imagine those spinning coins again. Now, you link them somehow, even if they're miles apart. The instant you stop one coin and see heads or tails, you know the other one instantly, too. Doesn't matter how far apart they are.
Wait, so they're connected across any distance? Like they have their own secret language that breaks the rules of like the speed of light?
That's the weird, cool part of entanglement. It lets you link things in a way we're still figuring out. It makes things like quantum communication networks possible. Imagine sending data that's almost impossible to hack.
Yeah, that would change everything. No more data breaches to worry about.
Right. It's exciting, but there's still a lot to figure out. But that's a perfect way to get into the next part. What can we actually do with all this quantum stuff?
All right, so we've got these qubits, this entanglement thing. It's all pretty mind-blowing. But what's the practical side? What can we actually do with quantum computers?
That's the big question, right? And the answer is, it's still a bit of both. We're early on, but the potential is huge. One area where quantum computers could really change things is cryptography.
Like breaking codes. That sounds like a spy movie.
It does, doesn't it? But the science is real. The encryption we use now, it's all based on math problems that would take a normal computer, like, millions of years to solve.
Yeah.
A quantum computer, though, theoretically, it could crack that code way, way faster.
Okay, now that's both impressive and a little scary. Like, what happens to online security if that becomes reality?
That's the thing, right? It's important to remember, we're not there yet. Quantum computers aren't cracking codes left and right. It's still mostly theory. But there are other fields where quantum computing is already making progress, like in medicine even.
Yeah, I read something about designing new drugs with quantum computers. How does that even work?
Imagine creating a drug at the absolute smallest level, like custom made for your DNA. That's what quantum computers might let us do. They can model how molecules interact so precisely. Regular computers just can't compare.
So we're talking about personalized medicine, drugs made just for you, maybe even cures for diseases we thought were impossible.
It's an incredible thought. Right. And it's not just medicine either. Quantum computers could be huge for material science. Imagine designing materials atom by atom, making them lighter, stronger, everything. For airplanes, for renewable energy, you name it.
Okay, this is getting hard to wrap my head around. There's so much potential. But gotta ask, are there any downsides? What's holding this back from changing the world tomorrow?
Yeah, and it does feel like there's got to be a catch, right? Like, what's the holdup? Why isn't everyone using quantum computers already?
Well, there are some hurdles, for sure. One of the big ones, these qubits we're talking about, they are picky, like really picky.
Picky how? They need things to be just right. We're talking temperatures colder than outer space. Even the slightest disturbance can mess them up.
So it's like trying to work with, I don't know, a computer made of snowflakes. Sounds like a nightmare to keep them running.
It's a challenge, that's for sure. And then there's the whole scaling thing. We keep talking about thousands, millions of qubits working together, but getting that many to cooperate, it's not just about making more, it's about making them work together perfectly. Each qubit you add makes things way more complex.
So what are scientists doing about it? Like, how do you even start to solve those problems?
It's a huge effort, lots of different approaches. Some are trying to find totally new kinds of qubits that are more stable, less finicky. Others are working on the materials, how to build these things better. And then there's the software side, these error correction codes, to try and compensate for the mistakes that happen. It's a super fast-moving field.
It's like we're almost there, but still figuring out the last few pieces of the puzzle. So realistically, when can we expect to see quantum computers changing our lives?
That's the million-dollar question. It's hard to say exactly. Think about it like the very first computers, though. Huge, expensive, mostly for governments and stuff, right?
Yeah.
It took decades for them to become something everyone could use. Quantum's probably going to be similar.
So no quantum phones in our pockets anytime soon.
Probably not. But here's the thing, even the little steps forward, they matter. The stuff we're learning from quantum, it's already helping in other areas, materials science, AI even. It's a really exciting time to be paying attention.
That's a good way to put it, exciting. Quantum computing, it's this whole new world of possibility with the potential to change, well, pretty much everything. We've got personalized medicine, unbreakable codes, materials we can't even imagine yet. It's going to be a wild ride. Big thanks to our expert for breaking it all down, and to you, our listeners, for joining the deep dive. Keep those questions coming because the future of tech, it's just getting started.